we're gonna start with the introduction of titration. Titration is a quantitative chemical technique used to determine the concentration of substance in a sample by adding a solution of known concentration to the sample until the reaction between the analyte and the titrant is complete. The reaction is typically monitored using an indicator that measures changes in pH. The endpoint of the titration is reached when the stoichiometric amount of titrant has reacted with the analyte, allowing the concentration of the analyte to be calculated based on the volume and concentration of the titrant used. In this video about volumetric analysis determination of acetylsalicylic acid in aspirin using titration. The titration involves reacting ASA with a base which is NaOH of known concentration until the acidic ASA is become neutralized. The volume of the NaOH required to reach the endpoint allows the calculation of ASA concentration in the aspirin sample.
Is the theory of acetylsalicylic acid. Acetylsalicylic acid is an organic compound commonly referred as aspirin. Appears as odorless white crystal or crystalline powder with a slightly bitter taste. Aspirin is used to treat headache, swelling, fever, and can even lower the risk of cardiovascular events like a heart attack if taken daily for people with high risk. This medication do not need prescription from a doctor or a physician. It can be obtained over the counter like a pharmacy. So how aspirin works? The medication blocks the production of prostaglandins by inhibiting cyclooxygenase, which is prostaglandin H synthase. So why aspirin is not prescribed for under 18? This is because during viral illnesses, aspirin can increase the risk of getting Raynaud syndrome, which can lead to permanent brain injuries and even death. Why does aspirin can cause Raynaud syndrome? Study shows that the condition progresses when damaged mitochondrial cells pair with viral illness or an infection. Symptoms of Raynaud syndrome increase when aspirin enters the body, which worsens damage to mitochondria. Damaged mitochondria causes the level of ammonia in blood to increase, followed by the swelling of the brain, which is cerebral edema and intracranial pressure.
Let's move on to the experimental sections. Before we start the lab, we need to make sure all the apparatus and chemical needed are ready to use. For apparatus, we need beakers, weighing scale, clamp, burette, pipette, heirloom Mayer flask, mortar and pestle, ring stand, funnel, and graduated cylinder. For chemical materials, we need 0.1 molarity of sodium hydroxide, distilled water, aspirin tablets, phenolphthalein indicator, and ethyl alcohol. Okay, let's jump to the procedure on how the lab was conducted. First, the burette and pipette was carefully rinsed and cleaned by letting the water flow out from the both ends. The pipette was rinsed and rotated with ethyl alcohol, and the alcohol was let flow out from its end. The burette was rinsed with sodium hydroxide. An aspirin tablet was ground into a fine powder by using a pestle and mortar. The aspirin powdered sample was weighed by using weighing scale, and the mass was recorded. The aspirin powdered sample was carefully transferred into the conical flask. 10 ml of ethyl alcohol was added to the flask and stirred. 25 ml of distilled water was measured and transferred to the flask. 3 drops of phenolphthalein were added into the flask, and then the solution was stirred with a stirring rod for a couple of minutes until it's completely dissolved. The burette was filled with 0.1 molarity of sodium hydroxide, and the initial reading of burette was recorded in the table. The NaO was added slowly through drops while swirling the flask until the solution turns into a very light pink. The volume of NaO used was recorded. Step 1 to 11 was repeated for trial 2 and 3.
Next, let's go through to the result of sample. So, with data, the lab procedure mentions 3 trials. For the first one is the molarity of sodium hydroxide that we use is 0.100 m. Next, for molar mass of acetylsalicylic acid, we use as 180.16 gram per mole. And for the sodium hydroxide that we use is, we know that 0.100 moles equal to 0.100 moles per liter. So let's move on to the result of sample for data table 1. So we have 3 trials, which is trial 1, trial 2, and trial 3. So for mass of aspirin tablet, we use the same mass for these 3 trials, which is 325 mg. For initial burette reading, for trial 1 we have 0.00 ml, trial 2 17.75 ml, trial 3 30 ml. For final burette reading, we have 17.75 ml for trial 1, for trial 2 we have 35.40 ml, for trial 3 we have 47.65 ml. Next, for volume of sodium hydroxide that we use, for trial 1 we have 17.75 ml, trial 2 17.65 ml, and same for trial 3, which is 17.65 ml. Next, for moles of sodium hydroxide, for trial 1 is 1.775 times 10 power of 3, for trial 2 1.765 times 10 power of 3, for trial 3 1.765 times 10 power of 3. For moles of acetylsalicylic acid that used, for trial 1 same 1.775 times 10 power of 3, for trial 2 1.765 times 10 power of 3, and same for trial 3, which is 1.765 times 10 power of 3. Next, for mass of acetylsalicylic acid that we use for trial 1 is 321 mg, for trial 2 318 mg, same for trial 3, which is 318 mg. Lastly, for percentage of acetylsalicylic acid in aspirin tablet, for trial 1 we got 98.46%, trial 2 97.84%, and same for trial 3 97.84%.
For the last slide is conclusion. In conclusion, titration is an analytic method where the concentration of one substance is determined by reacting with the solution of another substance. The objective is to determine the percentage of acetylsalicylic acid, or we call as ASA, in aspirin using titration was successfully achieved. Through the titration process with sodium hydroxide, we found the average percentage of ASA in the aspirin sample to be 98.05%. The results are within acceptable theoretical value to confirm the accuracy of the method. Overall, the titration method proved effective for quantifying acetylic acid in aspirin and underlining its value in pharmaceutical analysis and quality assurance.